Hello everyone and welcome to another RouTube video. In this video I'm going to go through Index Law 1 and 2 which students will be introduced to at Year 8. So I thought I would begin by outlining the learning objectives that will be covered in this video. The first one is to develop an understanding of the first index law. The second one is to simplify algebraic expressions using the first index law. The third one is to develop an understanding of the second index law. And the final objective is to simplify algebraic expressions using the second index law.
Okay, so index law 1. Okay, so the first index law states that a to the power of m times a to the power of n equals a to the power of m plus n. Okay, so I reckon the most important thing and the thing we're going to focus on first is actually trying to unpack what that actually means. Okay, so if we have a to the power of m times a to the power of n, you will see, and hopefully you already know, that both of these a's are what we call bases. Okay, so you'll clearly see there that both of the bases there are the same. Okay, and that's really important to sort of identify when we're dealing with the first index law. Okay, and then you'll see here we have our two powers. Okay, so you will obviously be familiar with the word powers, and hopefully you'll also be familiar with the word indices. Okay, so indices are just another name or another word for powers. Okay, so index being singular and indices being plural. Okay, so the green highlights they are the indices or the powers, and the yellow highlights both the a's are what we call the bases. Okay, so the first index law states that, we'll go through it again, so a to the power of m times a to the power of n equals a to the power of m plus n. Okay, so you'll see there that what we do with the base, we actually don't do anything to the base. Okay, so those two bases just join to make one base. Okay, so the base actually doesn't change. And what we do with the indices or the powers is we actually add them together. Okay, so it's really important that you understand that the first index law is all about these two operations. Okay, so it's all about multiplication and addition. So once we go through index law 2, you'll see how it's sort of similar but a little bit different as well. Okay, so index law is all about multiplication and addition. So if we have a look at the couple of questions that we've got just down here, okay, so we've just got here simplify the following. So we've got b to the power of 5 times b to the power of 4. Okay, so it's really important that obviously we're using the first index law, but if you got this question in a test or just in a isolated on its own, you should be able to identify which index law to use. Okay, and the way you do that is you identify that both of these bases are the same and the operation is multiplication. Okay, and that should once again tell you what you should be doing with these powers or these indices. Okay, so what we're going to do, we're going to have a go at the first question together. Okay, so I'm just going to write the first question down. So we've got b to the power of 5 times b to the power of 4. Okay, so if we have a look at the first index law, remember that the bases come together to just join one base. Okay, so it becomes b to the power of something. And what do we do with the indices? Well, the first index law tells us that we need to add them together. Okay, so it becomes b to the power of 5 plus 4. Okay, and we can all do that, which then becomes b to the power of 9. Okay, so there's your first simplified version of index law 1, or there's your first go at index law 1. Okay, and there's our final answer. So b to the power of 9 is a simplified version of b to the power of 5 times b to the power of 4. Now let's have a look at the second one here. So we've got c squared, or c to the power of 2, multiplied by c to the power of 7. Okay, so similarly here we've got the same bases, so both are c's in this case. Okay, so the variable or the pronumeral are c's, and the powers or the indices are different values, but it doesn't matter what values they are. Okay, most important thing is that the bases are the same and the operation is multiplication. Okay, so once again, let's have a go at this one together. So we've got c to the power of 2, or c squared, times c to the power of 7. Okay, so once again, both the bases are the same, both c's, so they join to become one base of c. And then what we do with the powers is the first index law tells us that when it's multiplication, we add the powers. Okay, so we're just going to have c squared, and then we've got plus 7. Okay, and that should equal c to the power of 7 plus 2 gives us 9. Okay, so that would equal c to the power of 9. And then finishing off this part with the third question. So we've now got x to the power of 9 multiplied by x to the power of 14. Okay, so we're dealing with bigger numbers here, but the same process and the same rules apply. Okay, so I've just highlighted both the bases. The bases are both x. The operation is multiplication, and the indices are 9 and 14. Okay, so the same steps, doesn't matter if the numbers are bigger, it makes no difference. Okay, so here we've got x to the power of 9 multiplied by x to the power of 14. Okay, so once again, the two bases join to make one base of x, and then the powers just get added together. The indices just get added together. So it becomes x to the power of 9 plus 14, which is therefore x to the power of 23. Okay, so there's a really brief and quick introduction into the first index law, which will continue going through a couple of other examples. Okay, so now we're going to continue with index law 1. So this time you're going to see these couple of questions look a little bit different to the previous ones, but we're going to follow the same process. So now we have 4x squared times 3x to the power of 6. Okay, now there's a really common error that comes with a question like this, and a lot of students think, well, the bases aren't the same, okay, because you identify that you've got a 4 and a 3 that are at the front of the pronumerals, okay, and we call those numbers coefficients, okay, but it's actually really important to identify that those coefficients, so that number 4 and 3, they're not the bases, okay, they are, as I said, they're called coefficients. Okay, so it's really important that we still go with the idea that the x is the base and the powers are 2 and 6, okay, so they are the indices. And once again, the operation is multiplication. So that's how you would identify which index law to use. Like I said, it's pretty clear that we're using the first index law, but like I said, if you get this question in a test or just in an isolated setting, you should know to use the first index law based on the multiplication sign. Okay, so we're going to follow the same process as we did in the previous questions, but this time we're going to add something to that process. So now you'll see those coefficients. Okay, so what we actually need to do is we need to multiply those coefficients, and you might say, well, why do we multiply them? Okay, and that's because the operation tells us that we need to multiply 4x squared by 3x to the power of 6. So now it's just an extra step to what we were doing. So now what we need to do, let's just multiply the coefficients first. Okay, so it's just going to be, we've got 4 times 3, and that's going to equal 12. So we got 4 times 3, and that equals 12. Okay, then what we'll do, now we're going to multiply the x to the power of 2 times x to the power of 6. And if you remember from the previous slide, that would become x to the power of 2 plus 6, which then becomes x to the power of 8. Okay, so now what we can do is we can take down both of our answers, and that becomes our final answer. So we've got 12, which is the coefficient, the base is x, and then the power, or the index, is 8. So the simplified answer of 4x squared multiplied by 3x to the power of 6 is 12x to the power of 8. Now moving on to the second question. Okay, once again I'm going to highlight just like I did in the previous question. So that we've got the 2 and the 6. They are coefficients. Then you've got the bases, the d and the d. And then now something a little bit different. You've got a 3 there, but then you don't have a power or an index there. Okay, it's really important to note that when there's no power, or there's an invisible power essentially, that just means that that's the power of 1. Okay, so a lot of people make a common error and just think that the power is 0. But that's going to come when we talk about the third index law. Okay, so it's really important to note that, and I might just rub that out just to show you once again. But if there's no power, so if it's just 6d or 2x or 3y or whatever it is, there's actually just a power of 1. Okay. And I'll just highlight that one in green as well. Okay, so now we're going to follow the same steps from the previous question. So we're going to multiply the coefficients. So it becomes 2 times 6, which gives us 12. And then now we're going to multiply the d to the power of 3, which is d cubed, multiply by d to the power of 1. Now we don't need to write the 1, okay, but it's good to know, or it's good for you to know that it's actually there. Okay, so then it's going to become d to the power of 3 plus 1, which equals d to the power of 4. So you'll see if you didn't know that that d meant that it's d to the power of 1, you might think that it was d to the power of 0. So then you would add 3 plus 0, which then gives you d to the power of 3. Okay, so it's a very different answer to the one that we got. Okay, and then we can bring our answer together. So we've got 12 and then d to the power of 4. Okay, so there's our simplified answer of 12d to the power of 4. Okay, so now we're going to have a look at index law number 2. Okay, so it's really similar to index law number 1 in the sense that, once again, we deal with the same bases. We still deal with indices, but this time we deal with division and subtraction as opposed to multiplication and addition. Okay, so it's a really similar process, but it's actually quite different as well. Okay, so it's really important to know when to use which index law. So whenever you get division, which we're going to have a look at now, you're going to use index law 2, multiplication index law 1. So let's have a look at the first example. To simplify the following, y to the power of 6 divided by y to the power of 3, or y cubed. Okay, so once again, we're going to follow the same process. So we've now got y to the power of 6 divided by y to the power of 3. Okay, now remember, how you would know to use this index law is the division. Okay, so the division, and what you're going to do to the indices is you're going to subtract them, because that's what the index law tells us to do. Okay, so we've now got y to the power of 6, and we're going to subtract the 3, which therefore gives us y to the power of 3, or y cubed. Okay, so we need to know when to use which index law and what to actually do. So index law 2, division and subtraction as opposed to multiplication and addition, as I said before. Let's have a go at the next one. So we've got r to the power of 12 divided by r to the power of 4. Once again, follow the same process. The r's, the bases are the same, so they join into one base, and then we subtract the powers, or the indices. So it becomes r to the power of 12 minus 4, which gives us r to the power of 8. And then the final one, now this one looks a little bit different, but it's really important to note that it's no different to the first two examples we went through. Okay, so what I'm going to do here is b to the power of 21 over b to the power of 11 is the same as b to the power of 21 divided by b to the power of 11. Okay, it's really important, and a lot of students get confused when they see one written as a fraction and one written with the division sign. It's really important to know that they are both the same. Okay, it doesn't matter which way you write them, but you'll see them in both scenarios, so you need to know what to do. Okay, so once again, I'm just going to write that down. Okay, so we've got b to the power of 21 divided by b to the power of 11. Once again, the b's come together, the bases are the same, so they come together to create one base. And then what we do to the indices is we subtract them. Okay, so we've got b, and then we've got 21 minus 11 gives us 10. So then we have b to the power of 10. Okay, so just like we did in the index law 1, we're now going to add some coefficients to index law 2. Okay, so simplify the following. 16m to the power of 7 divided by 4m to the power of 4. Okay, so once again, just going to highlight the coefficients. We've got 16 and 4. and then we've got our bases, which are our variables, and then we've got our indices. And once again, as always, really important to note the operation, because the operation leads you to work out which index law to use. So now let's go ahead and answer the question. So simplify the following: 16m to the power of 7 divided by 4m to the power of 5. As we did with index law 1, we're going to deal with the coefficients first. Okay, but this time it's not going to be 16 times 4, and the reason is because of the division sign. Okay, so now it's going to be 16 divided by 4. How many 4s go into 16? It's going to be 4. And then we've now got m to the power of 7 divided by m to the power of 5, which is then going to be m to the power of 7 minus 5, which is then going to be m squared, or m to the power of 2. And then once again, we can bring our answers together. So we've got 4m squared, or 4m to the power of 2. So it's the same process as the previous question. We're just adding the coefficient, just like we did for index law 1. Now what we're going to do is we're going to move on to the next question. And what I'm going to do is I'm just going to rewrite this one. So 18g to the power of 9 divided by 8g. Okay. Remember, the first thing you should identify straight away is that there is a power of 1 that's attached to that g. Okay, I'm just going to rewrite this as a fraction. So we've now got 18g to the power of 9 over 8g to the power of 1. So what we do is, okay, so we follow the same process. I'm going to highlight coefficients in orange, the bases in yellow, and the indices in green. Okay, so same process again. So 18 divided by 8. Now that's going to give you 2 point something. Okay, and we don't want to deal with any decimals. Okay, so that's why I've written it as a fraction. And now we can simplify the fraction as we would any other fraction. Okay, and what we actually do is we actually identify the highest common factor. Okay, so we identify the highest common factor in both of the coefficients. Remember, we always deal with the coefficients first. So what I'm going to do, I might just write down the question again down here. So we've got 18g to the power of 9 over 8g to the power of 1. So we're going to deal with the coefficients first. I might just highlight those orange just so we know what we're dealing with. So we've got these ones in orange. Okay, so what we need to do is, like I said, identify the highest common factor. So what number is the highest value that goes into both 18 and 8? Well, hopefully you'll identify, or what you can do is you can list all the factors, okay? But you hopefully will be able to identify that the highest common factor is 2, okay? And then you've got to see how many times does 2 go into 18? It's going to be 9. And then how many times does 2 go into 8? And that's going to be 4. Okay, so once again, I'm just going to rewrite the question again, but with these new values. So we've now got 9g to the power of 9 over 4g to the power of 1. Okay, so you'll see I'm not trying to do 4 steps in one. I'm really trying to step it out, and that will sort of help you, and you won't sort of make or less chance for you to make an error if you're not trying to do 2 or 3 things at once. Okay, so now you'll see there's no common factor between 9 and 4. So now my coefficients, I can't do anything else with the coefficients. So now what we're going to do is, now what we've got is, and I might just highlight them again, we're now going to deal with the g to the power of 9 and the g to the power of 1. So what we've got here is, I'm just going to rewrite on the right, just so we can see that it can be written another way. So g to the power of 9 divided by g to the power of 1. That is exactly what we have here. Okay, so it's really important, once again, as I said on the previous slide and just in the start of this question, the fraction can be written as a division sign, because that line that in the fraction, that's called a vinculum. Okay, and that just means divided by, or division. Okay, so if we have g to the power of 9 divided by g to the power of 1, what we'll do, we're going to subtract. We're going to subtract because it's division. So we're going to have 9 over 4, and then we're going to have g to the power of 8, okay, because we're going to subtract. But how do I know where the 8 goes? Okay, well, the 8 goes where there were more g's.
Okay, so there were more g's, there were 9 of them on the top. Okay, so we're going to get rid of, or essentially exhaust that. We're going to subtract 1g from both the top and the bottom. So we're going to subtract 1g from the g to the power of 9, and we're going to subtract 1g from g to the power of 1, which therefore gets rid of that g to the power of 1 and leaves us with g to the power of 8 on the top of the fraction. So there we have our simplified version of 9g to the power of 8 over 4. All right, now what we're going to do is we're going to combine both index laws to a simplifying question. So we've got here, simplify the following. We've got 15w to the power of 6 times 8s to the power of 9, all over 10w to the power of 4 times 4s to the power of 5. Okay, so you might feel a little bit daunting when you see a question like this, but please don't be, because we're going to follow the same process as we did previously, just a couple more times. Okay, so when you get a question like this, hopefully you'll be able to see that we're going to use both index law 1 and 2. Okay, and the reason is because I've just highlighted we've got multiplication, and that line, remember that division, that vinculum, that fraction, just means division. Okay, so we've got multiplication and division here. So best thing to do is, when you get a question like this, is to separate the question into two parts. Okay, so what we're going to do is we're going to deal with the top part of the fraction first. Okay, so everything on where the numerator normally is. Okay, and then we'll just leave the denominator, the bottom part of the fraction for now, and we'll bring that in a second. Okay, so what we're going to do is now we're going to pretend that bottom part's not there. So we've got 15w to the power of 6 multiplied by 8s to the power of 9. Now, what we're going to do is we're going to do just like we've done previously, and we're going to start with the coefficients, so the 15 and the 8. Okay, so we're going to multiply the 15 and the 8, so 15 times 8 gives us 120. And then we've got w to the power of 6 times s to the power of 9. Okay, now you'll clearly be able to identify that the bases are different. One's a w and one's an s. So you can't actually join those together. Okay, so we need to just write those separately. And what you normally do is just write them in alphabetical order. Okay, so it's going to be 120 s to the power of 9, w to the power of 6. Okay, clearly because s comes before w in the alphabet. And then we're just going to, now we're going to bring in the second part of the question. Okay, so now we've got the bottom part to do the exact same thing that we just did to the top part. So we've now got 10w to the power of 4 times 4s to the power of 5. Once again, start with the coefficients. So 10 times 4 is going to give us 40. And then once again, w to the power of 4 times s to the power of 5. We can't join together, so we're just going to list them and write them just like we did in the previous part. So s to the power of 5 and w to the power of 4. All right, so that's your first part. Now hopefully this will look a little bit more complex, but the same idea as one of the questions previously. Again, we're going to start with the coefficients. So what we're going to do is we're going to identify the highest common factor between 120 and 40. And if you identify a common factor, but not the highest common factor, that's okay. It just means that you need to go through the process a couple of times. Okay, but if the quickest thing and the most efficient way is to identify the highest common factor. So what number goes into both 40 and 120, and the highest of those, hopefully you'll identify that it is actually 40 in itself. Okay, so 40, how many times does 40 go into 120? It's going to be 3. And how many times does 40 go into 40? It's going to be 1. Okay, so now let's not try and do anything else. Let's just write what we have next. So we've now got 3 s to the power of 9, w to the power of 6. All over. Now we've got 1 s to the power of 5 and w to the power of 4. Now, what you'll see when we have a coefficient of 1, which we do on the bottom, you don't actually need to write that coefficient of 1. Okay, so basic algebra just tells us if it's a coefficient of 1, just like if it's a power of 1, we don't actually need to write it. So if you write it, it's okay, but we don't actually need to write it. So now what we can do, we clearly can't simplify the coefficients anymore because one's a 3 and one's a 1, which we've just cancelled out. So now we've got, and I might just highlight what we've got. Now we've got s to the power of 9 over s to the power of 5. Okay, and if we remember from the previous slide, what that means is, I'm just going to write it here on the right hand side, s to the power of 9 over s to the power of 5 just equals s to the power of 9 divided by s to the power of 5. Okay, and what we can do, we know it's division, so we know we have to apply the second index law. So we're going to subtract the powers, so it's just going to be s to the power of, whoops, I might just write the next step. So it's going to be s to the power of 9 minus 5, which is going to be s to the power of 4, which equals s to the power of 4. Now, once again, how do we know where the s is going to go? Well, there were more s's on the top, so therefore that's where they're going to go. There was 9 on the top and 5 on the bottom, so therefore we've now got 3s to the power of 4. And now we'll do the same thing in the green. So now we're going to deal with the w's. So now we've got w to the power of 6 over w to the power of 4. So we've now got w to the power of 6 over w to the power of 4. And just like the one with the s's, that is just another way of writing w to the power of 6 divided by w to the power of 4. Which again, we've got division, so we know we need to apply the second index law. So w to the power of 6 minus 4, which becomes w squared, or w to the power of 2. And once again, how do we know where it goes? Well, there were more w's on the top, so we're going to leave them on top. There were 6 on the top and 4 on the bottom. So therefore, we have an answer which we have finished. The simplified version of that fairly complex problem is 3s to the power of 4, w squared.